Okay, here we have a problem that states AB is a vertical tree. So they're going to give you a diagram in this case. Here for this one you are being given a diagram. So AB is a vertical tree or a vertical tower or a vertical pole, whatever it is, but it's a vertical. It stands 25 meters high. So from A to B is 25 meters height. So we put our labeling one time if we want. And standing on a level horizontal plane A, C, and D. So you have that plane, which are positions on the horizontal plane. So it's on a flat surface. CAD makes an angle of 120. CAD makes an angle of 120, so that's the angle of 120. While angles of elevation of the top of this tree B from C and D are 20 and 35 degrees respectively. So let's draw the information given to us. Okay, this is the diagram given, so we're going to use this also. So let's start. Bring a diagram here and we start to do our first piece. So we have here A, C, and D. We have a pole. Okay, this is B, this is A, this is D, and this is C. So according to this problem here, it says that AB is a vertical tree which stands 25 meters high. So this vertical height is 25 meters. We put that. Standing on a level plane ACD. ACD are on the horizontal plane, which are positions on the horizontal plane, which we have here. Angle CAD makes an angle of 120 degrees. CAD makes an angle of 120 degrees. So that's 120 degrees right there. This is 120 degrees. Okay, that's what the problem said. While the angles of elevation of the top of this tree from B, where is B? From B, the top of this tree B, which is the top here, from C and D are 20 and 35 respectively. So C has an angle of elevation here to be 20 degrees, and from D there's an angle of elevation of 35 degrees. So that looks like the diagram. So here you really have to visualize. These are flat surfaces. This is plane. These are vertical height. Now, if this is a vertical height, this must be at 90 degrees with this line. So let's put our 90 degrees sign. And then this must be at a 90 degrees also, because it is on a flat surface and this is a vertical pole. Alright? What else based on what we were told? Okay, the angle of elevation of B from C is 20. The angle of elevation of B from D is 35. Alright? So, based on the angles, you can say that D is farther from A compared to C. So now, based on this, they said, copy and complete the diagram given showing the length that represents 25. Okay, we did that. So we got that covered. The angles of 20, 35, and 120 mentioned. We got that covered also. Next part of the problem states the two right angles formed. Okay, these are the two right angles which were formed, because remember this was a flat surface and there was a vertical pole. So we have that covered. Calculate to the nearest meter, and this is where the problem comes in for working out. And the reason why they start the problem that way for you to label and you have it labeled, because that is to gear you up for what is coming, for the problem what you will be solving. Calculate, so let me put that here. Calculate to the nearest meter CA. I want to know what is this length, and then I want to know what is AD, this length, and I want also to know what is the length CD. So I want to know the three sides of the triangle, so I can now join this. Now, what is it that we have? Well, here, if you notice, the pole has a vertical height. This has a 35 degrees. So let's take this top piece and split it. This side here, let's look at it from this perspective. You have this point A, you have C, you have B. The height is 25 meters. This angle here is this angle, which is 20 degrees. If I want to know what is this length, I would use a trig ratio that uses opposite and adjacent at the angle, which in this case would be tan. So I put then tan of 20 is equals to AB, which is 25, over CA, which is the distance that we want there. So we cross multiply, we rearrange the equation, we end up with CA is equals to 25 over tan 20. So we rearrange and we get our angle, which is 25 divided by tan 20 equals 68.686. So round it off to one decimal point since we are working with whole numbers, and that gives us 68.7. So 68.7 degrees, 1 dp. So that's the length of EAC or CA. So let's put here 68.7 meters. Now, looking at this other triangle from this side, okay, we bring out our triangle this way. We put it again. This is just rough sketch, so the angles is not really important for us to make them precise. We know that this was a right angle, and this is a right angle. We have the height 25 meters still. We have the angle here to be 35. So now we want this length, which is AD. Here's A, here's D, here's B. We're going to use tan again. So tan of 35 is going to equal to 25 over AD. So AD is going to equal to 25 over tan 35. Okay, you're going to take your calculator again. You're going to substitute 25 divided by tan 35, and that gives us our value of 35.7 meters, 1 dp. Because we are working with whole numbers, so we put here 35.7 meters. So we have solved what? We have solved for CA, we have solved for AD. We're now going to solve now for CD. So now we can use cosine rule, okay, because we have angle on side. Do we have these other angles? No, we don't. So what we can do is that we can use the cosine to get this side. So we put in our cosine there based on the information. We put CD squared is equals to 68.7 degrees. 68.7 squared plus 35.7 squared minus 2 times 68.7 times 35.7 times cosine the angle of 120. Now be careful here. Let me show you something. Cosine 120, if you notice here, gives us a negative value. Do not take out that negative, keep it. There's a reason why. So you work this out, you get 68.7 square plus 35.7 square. That gives us here plus give us 5994.18 minus, you put here 2 times 68.7 times 35.7 times cosine 120. That gives us a negative value, but remember we have a negative here, so therefore this becomes a positive 2452.59. That's CD squared. So CD is equal to the square root of adding these two. You now end up with 5994.18 plus 2452.59 equals 8446.77. So CD is equal to the square root of that number, which now gives us square root 8446.77, gives us a value of 91.9 meters 1 dp. So we end up with here now 91.9 meters. So that's how we get that value for these three sides. Now they come to the problem here and they're telling you that some change was done. So we come back here again and they say later a stand 5 meters is placed at point C. This point C, something's placed here 5 meters, so you put this here 5 meters. Okay, this stand measures the angle of elevation to the top of the stand. This measures the angle of elevation to the top there. All right, so there's an angle of elevation. Now if this is an angle of elevation, there must be a line of horizontal, because remember angle of elevation is based from the horizontal. So this is the angle now. Okay, so we have that 5 meter, we have that. Let's just calculate the angle of elevation. So now I want to know what is this angle here. Well, let's see what is it that we have. If this is vertical, this is vertical and this is parallel, then this length from this point to this point must be 68.7. So you put here 68.7. Since this is 5 and from here to here is 25, then this height here must be 20. So now pull out this diagram that you want to work with. You actually have this image now. You have here 20, you have here 68.7. This is now the angle of elevation that we want, which is here. So we're going to be using tan here, so we put tan, the unknown angle, is equals to 20 over 68.7. Angle is equals to arc tan 20 over 68.7. Okay, that now gives us, take a calculator, I put inverse tan, open bracket, 20 divided by 68.7. That gives us now 16.2 angle of elevation degrees 1 dp. So this is now 16.2 degrees angle of elevation. So that's the angle of elevation for the last part. Calculate the angle of elevation which we have there, and that's all you need to be doing for this problem. But if you notice, we use tan primarily for this problem. We had to use cosine for one of them so we can get this side. So despite the problem may look complicated, it's not. Take them piece by piece. There are walls, there's a flat surface, so therefore there must be a 90 degrees formation there. And once there's a 90 degrees, then that means that you're going to be working with a right angle triangle. Since you're going to be working with a right angle triangle, recall sine, cos, and tan. If you notice, since it was a right angle, we were able to use tan given two sides or given an angle. Okay.